Welcome to This Explainer. Okay, let's dive right into this, because today we are undertaking a massive overarching goal: mastering the Cambridge Mathematics syllabus. Now, I know many of you watching have already built some incredible foundational skills in your earlier courses, whether that's syllabus 0580, 0606, 4024, 4037, or 4040. But today we are aiming at the absolute peak. We are focusing intensely on the 9709 AS and A-level mathematics syllabus, and even looking ahead to elements that bridge into 9231. Specifically, we are tackling one of the most notoriously challenging topics in the entire curriculum: vectors. And even more specifically than that, we're dissecting the incredibly intricate three-dimensional relationships between parallel, intersecting, and skew lines. To really understand what's at stake here, I want you to picture two different students sitting down to take this exact exam. Let's call them Alex and Sam. Now, Alex is a hard worker. When Alex sees a complex vector question, they absolutely overload their paper with raw mathematical facts. They write down every single formula they can possibly remember, but there is absolutely no structural analysis. It's just a wall of numbers. Sam, on the other hand, definitely knows the math, but Sam rushes. Sam completely misses the specific command word requirements of the question, failing to show the exact logical steps the examiner explicitly asked for. If you put their answers side by side, it's just a sea of red pen marks. Both of these incredibly smart students are going to lose heavy marks, and it's not because they don't know what a vector is, it's because they simply don't understand the strategy. Today, we are going to fix that completely.
So, I want to pose this really provocative question to you right now, and I want you to think hard about it. What truly separates a B grade from an A star in Cambridge mathematics? Let me tell you a secret. It is not just about raw calculation power. It's about how well you can build a bulletproof mathematical argument with stress-tested evidence and absolute 100% quality control. This explainer is your exclusive, inside look at exactly what principal examiners demand when they are grading your paper. Think about it. When an examiner looks at a massive 7-mark question asking you to determine if two vector lines are skew, they are not just scanning the bottom of the page for your final answer. If you just scribble down, the lines are skew, guess what? You might get literally 0 marks. 0! Because they are looking for something called the method mark strategy. They want to see the architecture of your thought process. They want to see you extract the data, set up the parametric equations, attempt to solve those simultaneous equations, and definitively, logically, prove the inconsistency. That meticulous journey, that step-by-step mathematical storytelling, is exactly the difference between settling for an average grade and securing that highly coveted A star. All right, here is our roadmap for today's explainer. 1. The A-star vector challenge. 2. The method mark strategy. 3. 3 critical exam mistakes. And 4. Thinking like an examiner. We're going to cover a lot of ground, so let's get moving.
Let's jump right into Section 1, the A-star vector challenge, focusing on the core principles of the Mathematics 9709 syllabus.
Okay, to truly succeed at the A-level standard, you have to fundamentally shift your mindset from merely calculating numbers to actively proving concepts. Vectors in three-dimensional space aren't just abstract numbers. They represent physical realities, actual directions, and real magnitudes. In 3D space, lines can be parallel, meaning they are traveling in the exact same direction but never touching. They can intersect, meaning they cross at one specific verifiable coordinate. Or, and this is unique to 3D space, they can be skew. Skew means they are not parallel, but they still completely miss each other. It's like two airplanes flying at different altitudes in completely different directions. What's absolutely fascinating here is the contrast between superficial breadth and analytical depth when you are trying to prove which scenario is actually occurring. Remember our student Alex, who just threw raw math facts onto the page? That is superficial breadth in a nutshell. Alex might quickly glance at the direction vectors, see they aren't scalar multiples, and immediately state, not parallel, therefore skew. Boom, done. But wait, that is a massive, catastrophic error. An A-star student knows that proving lines are skew requires rigorous analytical depth. You must first logically prove they are not parallel by showing the direction vectors are not proportional. Then, you must set up the position vector equations. You equate the I and j components, solve those simultaneous equations, and then, here's where the true analytical depth comes in. You must substitute those values into the k component to prove they do not yield a consistent result. That specific depth is exactly what the syllabus demands of you.
So, the crucial takeaway here is that the cognitive domains targeted by the examiner require precise definitions and clear causal relationships. Look at these 4 pillars: knowledge, application, analysis, and cross-topic connections. The principal examiner reports continually note that candidates who reference cross-topic connections achieve significantly higher marks. Now, when we talk about analysis and application in vectors, a powerfully effective way to structure your mathematical argument is by adapting a framework that top students use. It's called the Peel framework: point, evidence, explanation, link. For mathematics, this translates beautifully. Point, clearly defining what mathematical test you are performing. Evidence, extracting your exact line equations from the prompt. Explanation, showing your step-by-step simultaneous equation-solving process. And link, concluding exactly what that mathematical result means for the physical lines in 3D space. This framework forces you to hit every single assessment objective perfectly. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Awesome. Let's move on to Section 2, the Method Mark Strategy, unpacking the technical methodology for vectors.
This section anchors our entire narrative on one unshakable, golden rule of Cambridge exams. The process is just as important as the final answer. In the Cambridge 9709 exams, you will very often see the marking scheme allocate an M1 mark. That M stands for method mark. You actually get this mark simply for demonstrating the correct intention and setting up the correct analytical process, even if you make a tiny, frustrating arithmetic slip later on. But here's the catch. If you do not explicitly show the method, you do not get the M mark, and consequently, you automatically lose the A1 accuracy marks that follow it. Your grade just plummets. Let's walk through this procedural framework to secure every single one of those marks, step by step. Step 1. Extract and interpret data from complex texts. In vectors, extracting the data means correctly calculating the direction vector by subtracting the coordinate points provided in the prompt. Step 2. Apply correct formats and terminology. This is where you actually set up your parametric equations using the standard vector format the examiner expects. Step 3. Evaluate performance and draw evidence-based conclusions. If you solve for your parameters and they give you a mathematically consistent point across all three I, J, and K dimensions, your evidence-based conclusion is that the lines intersect. If they don't, your evidence definitively points to them being skew. This methodology takes what could be a messy, chaotic page of numbers and transforms it into a clear, compelling logical argument that examiners love.
And this brings us to the strict conventions for presenting your mathematical information. We're talking proper headings, correct terminology, appropriate formats, and clear annotation. Let's do a quick interactive workshop right now. Imagine a 60-second timer ticking down on the screen. If I showed you a paragraph of a student's working where they just wrote a massive jumble of X's and Y's without ever defining what vector they belong to, you would struggle to grade it, right? Well, the examiner struggles too. Ignoring formatting rules directly impacts your ability to get those method marks. When you transition from testing the I and J components to testing the K component, you need to annotate it. Literally write a tiny heading on your paper saying, "Checking consistency in K component." That clear annotation acts like a glowing neon sign, pointing the examiner directly to your method mark. It guides their eyes. It turns what could be a confusing red pen disaster into a highly satisfying green check mark. You are quite literally making it easy for them to give you an A star. I literally cannot emphasize this enough. Marks are awarded for the analytical process. Reiterate this core philosophy of the method mark strategy in your mind until it becomes second nature. The journey of your logical reasoning is exactly what the examiner is grading. They want to see the stress-tested evidence of your argument laid bare on the page. Applying this analytical process means ensuring that every single line of your working follows logically from the previous one. If you are claiming two lines are parallel, your analytical process must explicitly show the examiner that vector b1 equals some scalar constant k times vector b2. You absolutely must write that specific equation down. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, welcome back. Let's dive into Section 3, 3 critical exam mistakes. We are pulling insights directly from the principal examiner reports.
Let me tell you, these examiner reports are absolute gold mines. They're written by the very people who grade hundreds of thousands of papers worldwide, and they see the exact same frustrating errors year after year. Let's systematically run through these top 3 mistakes to build your defenses. Let's call this our Find the Flaw challenge. Mistake number 1, confusing cause and effect. In vector questions, students often find that their simultaneous equations don't yield a nice, clean integer, so they panic and immediately declare the line skew. That is confusing a difficult calculation with a mathematical proof. The actual cause of lines being skew is strict mathematical inconsistency across dimensions, not just that the fractions look messy. Mistake number 2, forgetting to check format and presentation. We constantly see students writing column vectors sideways or bizarrely mixing up IJK notation with column notation mid-calculation. It's a formatting nightmare that loses marks. Mistake number 3, providing answers not specific to the given context. If the question asks you to find the perpendicular distance between skew lines in the real-world context of two flight paths, your final answer needs to relate back to that specific context. Don't just leave it as a floating decimal. Don't lose sight of what the question is fundamentally asking you to solve.
Now, what's incredibly vital about this slide is the explicit examiner alert. The reports reveal that candidates consistently confuse key terminology, and it destroys their arguments. The golden rule, straight from the people holding the red pens, is this: always define terms before using them. Terminology confusion is a massive barrier to an A-star. Let me give you a classic example. If you use a parameter like lambda for your first vector line, you absolutely must use a different parameter like mu for the second line. If you just use lambda for both of them out of laziness, do you know what you're doing? You are mathematically stating that the two lines are moving at the exact same proportional rate at the exact same time. That is a fatal flaw that completely ruins your ability to find an independent intersection point. Define your parameters clearly, tell the examiner exactly what variables you are using and why you are using them. Don't leave them guessing.
To help you lock in this complex terminology and the exact sequence required for parallel, intersecting, and skew lines, the source material suggests a brilliant practical tool, a memory hack. You just create a mnemonic using the first letters of key vector terms. So let's invent a system right now to remember the exact analytical steps to check vector lines. Let's use the acronym PIES. P-I-E-S. P stands for parallel check. Are the direction vectors proportional? Always check this first. I stands for intersecting setup. Equate the two line equations using different parameters. E stands for evaluate components. Solve for lambda and mu using just two of the components, like I and j. S stands for skew test. Substitute those values back into the third component, the k component, to check for consistency. PIES. Parallel, intersecting, evaluate, skew. Keep that mnemonic in your back pocket. In fact, if we had a 30-second speed writing challenge right now, you could write one perfect Peel paragraph just by following PIES. Do this and you will never blank out on the step-by-step process during a high-pressure exam ever again.
Let's move into our final section, Section 4, Thinking Like an Examiner. This is all about high-level evaluation and critical analysis.
For this final part, I really want you to step into the shoes of the person grading your paper. When an examiner looks at your vector calculation, they are not just acting as a human calculator verifying your arithmetic. They're acting as a judge of your logical reasoning. To secure that A-star, you need to deeply understand the higher-order assessment framework they are operating under, which this donut chart visually demonstrates. It is split into 3 distinct levels: descriptive, analytical, and evaluative. The descriptive level is the bare minimum. It's just stating the coordinates or writing out the basic vector equation. The analytical level is where you actively apply the method mark strategy, carefully setting up those simultaneous equations to test for intersection. But the absolute top tier, the evaluative level, demands comparison and justified recommendations. Evaluative thinking means looking at your final mathematical result, say finding out the lines are indeed skew, and being able to mathematically justify why your specific method proves this without a shadow of a doubt. It is linking the numerical evidence directly back to the spatial reality of the vector lines in 3 dimensions.
To truly operate at that elite evaluative level, you must break down exactly how to evaluate your own evidence quality. This is an absolutely crucial skill for squeezing out the highest possible marks on these complex vector questions. Look at these bullet points. Identify limitations, note assumptions made, consider alternative interpretations, and assess the effect on conclusions. While this might sound a bit theoretical, in a high-stakes math exam, it translates to rigorous, systematic double-checking. Ask yourself, did you assume the lines intersected just because you found a neat numerical value for lambda, without actually checking if that lambda works for the mu parameter in all 3 spatial dimensions? Did you consider the alternative interpretation that the lines might be skew? Evaluating your own work requires what we call a time management matrix, budgeting and saving exactly 60 seconds at the end of a long question to actively, intentionally verify your third component. That is the ultimate quality control. It stress tests your evidence before the examiner ever even sees it.
So, we arrive at our final empowering question. Are you ready to apply the method mark strategy and secure that A-star? You now have the complete mathematics answering system. Remember the 3 rules that guarantee top marks: command word decoding, Peel framework application, and the time management matrix. You know the profound difference between superficial facts and analytical depth, and you have the evaluative mindset required to definitively prove whether lines are parallel, intersecting, or skew. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to add Ace the Exams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.